Hello and welcome to our first video on hypothesis testing. We often use hypothesis testing when we compare new products or new theories with the old ones to decide which one is better. The best way how to understand hypothesis testing is by looking at some real-life example. So you can just pause the video, read this question, and then once you've read it, you can unpause the video and we will start doing it together. And our problem here is that we are trying to solve is the new cream that the company developed better than the old one? So the first thing is that we have to realize that there are three important points we need to understand. First thing is that we don't know what the probability of success of the new cream is. So to do any calculations, we always use the probability of the old product or theories. Because we know how successful they are. In the example above, we use the binomial distribution where p equals 0.55. The second important point to remember is that when we calculate the probabilities, we never calculate just one value, because the numbers would be too small and it will not help us to make any decision about whether the new cream is better or not. So instead, we calculated the probabilities of regions. In the example above, we calculate probability that x is more than or equal to 37, which is the region of the binomial graph, starting from 37, which is the number of patients it healed, up till 50. So we always calculate the probability of regions, not just one number. And the third important point is actually, and this is the essence of the hypothesis testing, what do we actually calculate? So we will calculate the probability that the old cream would also heal 37 or more people. If this probability is a very small number, for example less than 0.01, it means that the old cream would almost never be as effective as the new one. There is a very small chance that it would also heal 37 people if this probability is a small number. And in this case, we conclude that the new product is better. If the probability of the old cream healing 37 people is not very small, so any number bigger than 0.01, 5% or 10%, it means that the probability of the old product healing 37 or more people is not small. And in this case, the conclusion is that the new product is actually not better. If you need to read it a couple of times to really understand it, you can pause the video and read it a couple of times. In our example above, we have got a sample of 50 people. The old cream had probability 0.55. So to calculate probability of x is more than or equal to 37, you can use your calculator. It's CD button on your calculator, cumulative distribution, and the answer is 0.0045. This is quite a small number, definitely smaller than 0.01. And so in this case, we conclude that the new cream is more effective. This whole process can be summarized in 3 steps. First step is we write H0 and H1. The probability of the old product or the old theory is called the null hypothesis. And in our example, this probability was p equals 0.55. So we can write it here. The new product or theory that we are actually testing is called the alternative hypothesis, H1. And in our example, it was that the company was expecting the probability to be higher than 0.55. Then we calculate the actual probability. And again, when we do calculations, we never calculate just one value, but always the whole region. So in this case, from 37 up till 50. If the new cream healed even more than 37 people, then that's even better evidence that it's better than the old one. Here are the calculations. We already know that the answer is 0.0045. And the third step is always we compare the results to the significance level, and then we write down the conclusion of the test. So the small probability 0.01 that we used in this question to decide whether the new product was more effective or not is called the significance level. Usually it's 1% or 5%, and in exam you will always be given what it is, so you don't need to worry about it. So the important thing is that whenever the calculated probability is smaller than the significance level, the conclusion is that the new product or new theory is better. In our example, again, it was less than 0.01, so the result was significant, and we can write that there is enough evidence to reject the null hypothesis and accept the alternative H1. It's also good always to write the answer in the context of this question, and so we can write that there is evidence that the new cream is better. So let's look at one more example. Again, you can pause the video, read the question, and then we will start solving it together. So we are trying to test at 5% significance level if there is evidence to support the garage's claim that in their garage the cars are actually failing less than 30% of their customers will fail MOT. So again, the first step is to find H0 and H1. H0 is always the regular case, so in that area the probability of failing was 0.3, 30%, and the garage's claim is that for their garage is less than 0.3, so H1 is that P is less than 0.3. Now there is an important question we have to ask ourselves when we do the calculations. Now in step 2, we already know we have to calculate the whole region, but is it the region from 3 to the left, or the x is less than or equal to 3, or from 3 to the right, x is more than or equal to 3. What we saw in the previous example about the cream, that H1 was P is greater than 0.55, and we calculated the region that x is greater than or equal to 37. And in this example, where H1 is that P is less than 0.3, we will have to use the region x is less than or equal to 3. So it means that the inequality sign in our calculation here, the red sign, must be always the same like the sign in H1. And because here in H1 is that P is less than 0.3, we have to calculate that x is less than or equal to 3. So in this question, we've got sample of 15 cars, so n is 15, P is 0.3, and 3 cars failed. This is called the observed value of the test. So doing the calculations on your calculator, again, you can use the PD button, the CD button, cumulative distribution button on your calculator. You will get the answer of 0.297. And this probability has got a name. It's called the p-value of the test. And now we can go to the third step. We can see that 29.7% is definitely more than 5%, so the result is not significant, and there is no evidence, there is not enough evidence to reject H0. And again, in the context of this question, it means that the claim is incorrect, and the probability of a car failing the MOT is not less than 30% in that particular garage. So that's the end of this video. Thank you for watching, and I'll see you in the next video.